Hello, so let's look at how to calculate the universal gas constant in different units. So there are a couple different units for the gas constant, and I put them down here in your data sheet that you have. And you can interconvert between these using your conversion factors for your different, what do you call it, for your different quantities, for your different units in liter, atmosphere, mole, and Kelvin. So the most important one, so you can't really do anything about mole and Kelvin. But of course, your pressure and your volume units have some sort of relationship. So pressure, we can have atmosphere, we can have Pascal, we can have kilopascal, we can have torr, which is similar or equal to millimeter mercury. And those are about the ones that we can have there. Then for volume, you can have liter, and of course, you can have cubic meter. So those are the different units that we can convert the R gas constant to. So I'm going to do one of them, and then you can perhaps just check the rest, because I mean, they'll have exactly the same format. So if we take R is equal to this 0.082057 liter atmosphere per mole per Kelvin. We take that. And let's say we want to get it to somewhere, we want to eventually end up with this 8.3145 cubic meter Pascal per mole per Kelvin, which you will see is exactly the same as saying a joule per mole per Kelvin, because cubic meter Pascal is a joule. So this is a joule. But anyway, so we want to get to that unit. How do we get that to that? So let's start with writing it in a better notation for us to work with using our dimensional analysis. So you'll have liter atmosphere per mole Kelvin. Okay. Our first step is we want to get rid of atmosphere, let's say. Atmosphere, and we want to get to pascals. So we want Pascal on top here. It turns out that in one standard atmosphere, there's 101,325 Pascal. Okay, so that gets rid of atmosphere. So atmosphere is going to drop away there. The next thing we need to get rid of is the liter. So, that's really bad. Is the liter. So we want to get rid of liter, and we want to end up with cubic meter. And in 1 cubic meter, there is 1,000 liter. So then we get rid of the liter unit. So if we quickly do that, then it's going to be the same as 101.325 multiplied by 0.08 whatever. And you see it's essentially 100 times 0.08. And that's why it is then 8.3145 cubic meter Pascal divided by mole times Kelvin, which is exactly what we have there. Then you can just immediately identify that cubic meter Pascal is a joule, because a joule is a kilogram per kilogram cubic meter, or Newton per something. I can't actually remember, but you can go check what a Newton is. So in other words, this is 8.3145 joule per mole per Kelvin. So they were at least done 3 of them. So you can go and switch in between them. What I'm interested to know is why, for example, are those two equal? or these three equal. So think about what the relationship is between cubic meter and Pascal, and between liter and kilopascal. You'll see it's exactly the same thing written there in her hidden notation. And remember, 1 atmosphere and millimeters mercury is going to have some sort of relationship. Millimeters mercury and torr are essentially the same thing. So you can go and interconvert between them, just using exactly this method that I showed here, and you should get all of them. All right. Thank you for watching.